Alright, this is a quick video for assignment 5, worksheet 9.1c, dealing with correlation and determination. On these first two, on this first page, you're just going to put these numbers into the list on the calculators. So I put all the x's here in list 1 and put all the y's in list 2 for this problem. And then all you're going to do is you're going to hit stat, calculate, go down to linear regression, hit enter. Second, I put it in list 1, comma, and list 2, so I hit second 1, second 2, and it pulls up something that looks like this. So you just hit second, then the number 1, and then comma, then second, and then number 2, put it all in. You hit enter, and as long as you've done the stuff on your calculator like you were supposed to, it tells you what A is, what B is, what R squared is, and what R is. Remember, A is your slope, B is your y-intercept for these. If we use that number 4, if we use the one that's on farther down, it like switches. So for this one, it says write your equation. So y hat equals we'll say 0.98 x plus our b is 3.17. So that's our equation. We can write in r and r squared. R is about 0.941. Oops, I'm sorry. R is, I was looking at the wrong one. R is 0.9699. We probably could just round that off to 0.97. And R squared is the one that's 0.9491. Oops. 0.941 I meant. So now we have that. To figure out our strength and our direction, we just look here at R, and since it's 0.9699, about 0.97, number one, it's positive, so the direction is positive, and the strength is strong. We could have wrote that a little better if I'd turned around and wrote strong positive. Then they ask us to explain R and R squared. Well, R just tells us what we just wrote down there, that there's a strong positive correlation between X and Y. And then R squared, that's the new thing that we had. R squared tells us, if we look right here, and we could probably just make it 0.94, so that's about 94%. And what that means is, for R squared, that about 94% of variation in Y can be explained. And about 6% of the variation and Y is unexplained. And it's not the greatest mathematical way to explain what R squared is, but being that we're not in the classroom, that's about the best I can tell you for now. So what you're saying there is there's a reason why if we drew a scatter plot, and we really don't have to have the scatter plot if we just look at the equation, there's a reason how come some of the y's vary off of the line of fit or the regression line, and we can say that the variation in the y can be explained by the relationship between the x and y. So again, I'm probably not helping anything by trying to explain it to you, but we can, so 94% of the variation, we just sort of take it that can be explained just by little things that are in the data, whereas there's 6% that we can't really explain. And when you have something that's this strong where 94% can be explained, 6% can't be explained, that's means there's a pretty strong correlation between our x's and our y's. So if we make a prediction, if we like picked x to be 8, we could get some really good idea about what y is going to be. Then the next thing says use the chart. That's this chart. Use the chart with alpha being at 5%. Is the correlation significant? And remember here, what we want to do for this is we want to decide if the number from the chart is greater than or less than our alpha. So we know our alpha is 0.05. I'm just going to write this down here, then I'll write the answer out to the side. And we're going to decide from the chart, we know that we had n was 10. I'm sorry, this isn't right. We want the chart number over there. So we want the chart number over here, and we put our R over here. 9699. Wasn't paying attention to what I was doing. So we look at the chart. We're at 5%, and our N is 10. That means we're right here, 0.632. And R is greater than that. And if R is greater, then that tells us, yes, there is significant correlation. So yes, correlation is significant. Go down to the next one. Hopefully I'll explain this one a little better, a little quicker. Punch all those numbers into our calculator, which I've already done. We go over to go to stat, go to calculate, go down to linear regression, hit enter. I put mine in on list 3 and list 4, so second 3, comma, second 4, hit enter, and it gives us our A, our B, our R squared, and our R. So our equation, I'm just looking at that, our equation is going to be y hat equals the A, which is negative 0.877, times x plus our B, which is 9.72. So that's our equation. Our R is negative 0.9132. We don't really have to go out that many places, but I just do each time. And our R squared is 0.8339. Our strength and our direction we can get from right here, negative, and 0.9 tells us it's pretty strong, so I'm just going to write strong negative, so it's got a strong negative correlation. Our explanation, our R, tells us what we just wrote. There's a strong negative correlation between X and Y. And the R squared tells us, if we just look at the 83.83, that's 83%. So about 83% of the variation can be explained and that means about 17% of the variation is unexplained. Go to our chart, our R, and remember we want the absolute value of the R, and the absolute value of a negative 0.9132 is just 0.9132, and then we're going to get our number off the chart with alpha at 5, so 5%, and our N this time was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so N is 10 again. So we look on here, 5%, 10, still 0.632. And our R is bigger than that, so that tells us yes, the correlation between the X's and Y's is significant. Alright, on number 3, second page, number 3 and number 4. Again, if you need to put in the numbers in your list. If you need to clear a list, you go down to number 4 right here and you can clear it. So you could do that. I've already put the numbers in my list. So all I'm going to do is go over to calculate, down to linear regression, hit enter. I put the numbers for this one in list 1 and list 2. So second 1 comma second 2, hit enter, and it pulls up A, B, R squared, and R. Again, your A is your slope, your B is your y-intercept, so y hat equals A is 0.552, let's say, times X, and then our B is a negative, so this is going to be minus this time, 0.977. So again, the B there tells us that where X would be 0, if X was 0 right here, the y-intercept tells us that we would be at negative, about -1 or close to -1. The slope tells us for every 1 space that the X goes to the right, the Y goes, in this case the Y goes up 0.552, or goes up about a half. Our R this time is 0.5873. and our r squared is 0.3449. We look here at our direction for r, and you'll see that 0.58. Remember, r goes from -1 to 1 and 0 in the middle here. The closer we are to -1 or 1, the stronger the correlation. The closer we are to 0, the less correlation there is, the less that the variables are related. This one is 0.58, so it'd be somewhere about in here. So this is sort of a weak, and it's positive, so it's a weak positive correlation. Now we're going to explain each of those. R just tells us what we just says, that that there's a weak positive correlation between X and Y. So there's just a weak positive correlation between the two variables. And then r squared, we look here, if you just look at the first two numbers, that's about 34%. So that means 34% of the variation is explained, or can be explained. And about 66% of the variation is unexplained. So you notice on this one it's not very good. We can only explain why the y's vary so much, about 34% of the time, and 66% of the time we have no idea. We can't explain why the y is varying so much. And again, that's where we got a weak correlation here, so it means that the x's and the y's aren't really related all that real well to each other. Next one, I grab my calculator again, go to stat. I've already punched them in the list. You'd have to punch in all of those numbers in the list. Oh, I'm sorry, I forgot to do the last thing on this one here, using the chart. So if we use the chart, we want r over here. R is 0.5873, and we grab our chart, and our n this time is 1, 2, 3, 4, 5, 6, 7. So n is 7. Our alpha is 5%. So we go to 7, 5%, it's 0.754. And you'll notice this time that the number from the chart is bigger. So that allows us to say no, there is no significant correlation, or the correlation is not significant. So since our number from the chart was bigger than our r, we can say that the whatever correlation there is isn't really significant, and it doesn't really mean a whole lot. Now we go to number 4, and I've already put them in my calculator, put all the numbers in the list. So I go to stat, calculate, go down to linear regression, hit enter. This time I put them in list 3 and list 4, so I hit second 3, comma, second 4, hit enter. Tells us A, B, R, R squared, and R. So our equation this time is going to be y hat equals negative 4 or negative 0.463 times x, and our b this time is 13.315. So plus 13 point, we'll say 13.3, yeah, 13.315. Again, I probably went out a little farther than we had to on some of those, but then our R is 0.784, and our R squared is 0.615. Our direction and our strength, we look here, R is positive, so it's positive, and it's sort of, the strength is 0.78, so sort of, it's not really strong, but it's not really real weak either, so it's sort of in between. So I don't know, we could maybe say, and there's different ways to say this, and if you get into it more, you'll know it better, but maybe we'll just say it's got a medium positive correlation. It's not really a great way to explain it, but then down here our explanation, our R, and I'm just going to write what we just wrote there, is a medium positive correlation between X and Y. And our R squared, when we look at that, look at the first two numbers, so we can say about 61% of the variation is explained or can be explained. And about 39% of the variation is unexplained. So again, it's not real strong and it's not real weak, but so we could make a prediction, but it's probably not going to be the greatest prediction off of what we have here. And if we look at our chart, we're going to compare R, which is 0.784, to our number from our chart. This time our N was 1, 2, 3, 4, 5, 6, so N is 6. And we want our alpha to be 0.05, so 5%. Well, if I look at 6 and 5%, 0.811. And you'll notice that our R is just a little bit smaller than that. So that tells us that there's no significant correlation. So we really shouldn't be making predictions off the information that we have, because what correlation we do have isn't significant to say that the X or the Y's follow off of the X's. Right, on the next page, I've already graphed my points. On the bottom, I went by each line counts 2.5. And then going this way, again, your little break there tells you that we didn't start at 0 going on the Y. I started at 2.5 and I just went up by 0.1 each time. And my graph ended up looking something like this. You want to try to spread it out as much as you possibly can to make your graph look the best it possibly can. Again, you didn't have to do what I did here, but that gives you some idea, maybe one of the better ways to do it. And it says draw in a regression line on the graph. Well, it looks like our regression line might go, again, we want hit a couple of the points, and we want as many points on below the line as are above the line. So maybe, yeah, that's not very good. Maybe something in there about like that. Again, that's our regression line. Mine's not drawn the greatest, but just something in that area so we get some idea. One of the things we can take from it, we know it's going negative, so it's the direction would be a negative. For the rest of the stuff, I put all the stuff in list 1, list 2, I think. Make sure here, yeah. On my calculator, so if I go to stat, calculate, down to linear regression, I'm going to put in second, list 1, comma, second, list 2, hit enter, and it's going to tell us our A, our B, our R, and our R squared. First thing they want us to do is write an equation for the line. Remember that your A stands for your slope, your B stands for your y-intercept. So y hat equals, our slope this time is negative 0.038, we'll say, x, and our B is 4.26, so plus 4.26. Then it says describe the direction and the strength of the line. Well, the direction is negative and the strength is, I'd say probably strong. If we look at our R here, that sort of tells us 0.95 that it's strong. So we'll write strong negative. Our R is 0.952, we'll say. And our R squared is 0.91. Next it says explain what R tells you about tells you about how hours of TV watched per week is related to GPA. If alpha is 0.01, is the correlation significant? So this is telling us that there is a strong correlation. And I should have put negative. There's a strong negative correlation between hours of TV watched and a student's GPA. So the more hours of TV you watch, the more your GPA goes down. And then we want to look at this. We know that our R is 0.952. We want to see if it's bigger than or smaller than the number from the chart. This time we had our N was 10. And something I should have said over here, these numbers just told you student 1, student 2, student 3. They didn't really mean anything to our graph. These are the numbers that we wanted to put in our graph. Should have said that at the beginning of this problem. Hopefully you figured it out. If we look at our chart, N is 10, and this time we want a 1% level significance. So if we go down to 10, 1%, Notice for a 1%, the number from the chart gets bigger because we're trying to be more precise about it. 0.765 instead of 0.632. And we notice here that R again is bigger. So that tells us that there is significant correlation. So then when I have an argument with the student about if they watch too much TV, it causes their GPA to go down, I can use this information to show that there is data that backs up my point. Hopefully that helps. Sorry the video was longer than I wanted.